In this video, we're going to cover how to conduct a hypothesis test using a graphing calculator for means. And so we're going to be using the z-test and the t-test in our calculator. So if you click on the stat button, we're actually going to the t-test first based on our example from the previous video. So this is option 2. And if you look, you can notice that there's a data option in the calculator. This is where you can enter your data into a list and conduct a hypothesis test. But in our class, we're going to use the stats option. And so inside this option, you can see that there's a mu naught, x bar, s sub x, and n. And so from our previous video, we were looking at the mean ages of students that attend VCU, and we wanted to test if that mean age was less than 21. And so from our previous video, we can plug in each of our values. So mu naught, this statement comes from your hypothesis test, and it's the number that you are actually testing. In our case, we were looking for the mean to be less than 21, and so that would be our mu naught for this problem. Your x bar is always your sample mean. So in our problem, the sample mean was 20.4. And then the sample standard deviation was given to us as 4.4. Notice there is no option for sigma, so when you use a t-test, you do not know your population standard deviation. And for the other part of our problem, we had a sample size of 40, and we had a less than test, so we're going to use this second option. If you have a not equal to test, you'll use the first option. This is the less than option, and this is the greater than test. So you can change that according to the problem that you're conducting. And so finally, I'm going to ask students to use the draw feature. And the reason that I ask you to use this feature is because it'll show you the type of test that you're conducting, which in our case is a less than test. And it's going to give you the t-score as well as your p-value without confusing you with other options. So you need to report both of these values, and then you're going to compare your p-value to your alpha. In our problem, we were comparing to 0.05. This number is greater than 0.05, so we would fail to reject and we would have insufficient evidence for our conclusions. But now if we go back to stat, before I move on to the z-test, if I click on the t-test one more time, but I show you the calculate option, notice that you get the exact same values. You're given a t and a p, and so you can just use these two options without drawing the distribution if you'd like. But again, just make sure you're reporting your t-value and your p-value. So if I go under stat and now we go to the z-test, you can see that there's an option for a population standard deviation. So the main difference here, you will still put the same value from your hypothesis test, always goes into mu naught. Sigma is now going to be a population standard deviation. So let's just say, for example, that we have 3.5 as our population standard deviation. Again, you're going to plug in your sample mean, you're going to plug in your sample size, and then just so that we can see, let's say I have a greater than test. In this case, you can either calculate or draw. I'm going to hit draw so that you can see that in this case, it'll show you that we're doing a greater than probability. Our z-test gives us a negative 1.0842. You need to report this value. And the p-value for this problem is 0.86, which is really big. It's greater than alpha. We would fail to reject, which gives us insufficient evidence to conclude. And so again, if you need help with interpretations, just watch the previous video. And again, the difference is that when you do a z-test, you know your population standard deviation. When you do a t-test, you do not know your population standard deviation.